All right, we're recording. Sorry to cut you off, John.
Yep. So yeah, like I said, I had a number of conversations where the transpiler came up with NSIB, and I think he's got a good idea what the concept is and a little bit of what we're doing there. But yeah, I think if you could go through and show exactly what the transpiler does, and then like some really good use cases, he could. I'm sure he'll have some good questions and some good ideas and potentially some places it could be applied. Obviously for us, the generation of C# for adapter SDK is very helpful, but you know, there's definitely some other use cases it could be applied to. So I think if you could go through some of that, that would be great.
Yeah, I'll go ahead and share my screen just to kind of have something to point to. Um, so I guess to start off uh, with the basics of where the MTConnect standard is right now, is that the standard itself is maintained through a SysML model. Uh, so the architects currently of the standard, they're using Cameo to design the MTConnect standard, and the design framework that they're using is SysML. Um, as an example, the Institute has provided this MTConnect Model Browser, and so I don't know if you've used this before.
I know this is HTML model browser, but I haven't used this one that much.
Okay. Yeah, so I guess
Because
this
of the.
is, I'm sorry, go ahead.
No, go ahead.
Okay.
Yep.
So I guess this model browser, it's a static website that's automatically generated from Cameo. So Cameo generates a bunch of HTML files based off of the structure that they've defined in the SysML model. And then Will Sobel currently has additional tools that he runs after generating this static website to kind of clean up and add different links like these to kind of interconnect the static website. And I think he also made it to where you could search. But this model browser is a significant step forward for understanding the standard, right? Because I can search for any of the data items and get an explanation of what the intent is behind these different data items. I can explore all the other types of data that can be communicated via MTConnect, and it's very granular, right? So if we have like deceleration, for example, here, there's a main type, but then there's also subtypes for this particular data item type, and you get accurate definitions for each level. Um, so
So moving away from a lot of the PDF documentation that you went through while you were a student or a
Right.
PhD student trying to come up with the MTConnect implementation for a machine.
Mhm.
Now
Right.
instead of navigating a bunch of PDF files,
Mm-hmm.
you could
Yeah.
navigate the model browser.
Yeah.
So yeah, I'm sorry. Go ahead. It's a
Oh, yeah. So basically, in my understanding, this model browser is kind of a web version of the MTConnect PDF documentation, right? So
Mhm.
when I was first developing the MTConnect, I had to go through entire document to understand
Mhm.
the structure and the standard, because I
Mhm.
I I I don't want to make I don't want to make the any mistake on the data structure and the standard.
Mhm.
So, well, I think in that way, I guess that is tiny one for application of this model browser, but
Mhm.
in that sense, this is really useful and helpful to developing the MTConnect structure.
Mhm.
Yep.
Yeah, exactly.
Yeah.
This is far better than the PDF document. And I'd say probably one of the most powerful parts of this in terms of application development would be the introduction of the introduction and deprecated fields for a lot of uh, these classes. So these are indicators of when certain parts of the standard were introduced to the standard, as well as potentially when they were deprecated. So if we look here at the list of sample types, there's some of these that are crossed out. That's because they were deprecated, at whatever version. So that's also very helpful. If you're, let's say, in the context of some of your work, if you're trying to, develop a machine learning algorithm off of a data set, you may not want to potentially rely on, something like amperage as a core piece of your data model because it may not exist in all implementations of MTConnect. Does that make sense?
Yep. It makes sense.
Yep. So, like I said, this model browser has been, a huge step forward for implementers of MTConnect. Anybody just trying to understand the structure. And it's also very well up to date with the current standard, right? It directly is derived from what is written into the standard. So that is a nice peace of mind that there's no kind of communication gap between, the architects of the standard and whoever's writing the PDF document, right? Because this website is derived directly from the definition of the standard. So with that in mind, as we talk about the transpiler, part of how the transpiler came to be is that for us at TAMS, we had a need of being able to validate implementations. So our process was to look at a device configuration file, the XML file that represents like a probe request. And see if we can find an example here. Yeah, so one of these MTConnect devices responses. Let's see. Yeah, I'm sure somewhere in here there's an example. But what we needed to do is we needed to look at an implementation of the MTConnect agent and validate that the vocabulary used and the structure of the device and component structures were going to work well with our monitoring application. Because we ran into a number of instances where the vocabulary was all over the place, and they say that it's an MTConnect implementation, but really it's just XML. Like they don't use the right vocabulary, they don't use the right structures. And the process for validating that by hand was literally pulling up the files in Notepad. Like I would pull up, like the NIST implementation as an example, and I have to go line for line looking at these data items and then looking up the category and type. And it used to be that with the PDF version, I'd have to like Control F in the PDF and find wherever position was, make sure that it was in the sample section of the PDF, and then make sure that actual was a valid subtype of position. And then you got to look somewhere else to figure out what the right, default units of measurement are. So it's just a very grueling process. So we ended up developing an automated validation tool that was we hand wrote all the code by looking through each version of the PDF documentation and in C# we wrote out all of the vocabulary into an object-oriented library, right?
Yep.
So this library allowed us to automatically validate a large portion of this work. or automate a large portion of this work. However, that process of keeping that library up to date with each version of the standard was very taxing. It would take me a minimum of a week to introduce the vocabulary between each new version. So what I was looking for was, now that we have a SysML model that backs the MTConnect standard, is there a way that we can take that rigid structure of SysML and automate the development of, our C# code, right? So just to give you kind of a peek in the behind the scenes of that model browser. So the content for this site is essentially derived from this content. So this is another export from Cameo. Cameo allows you to save out the SysML model in the form of XMI, which is an XML document. And this contains the full definition of the standard. So you'll see down here below, there's 11.5 million lines of XML. It's a very large file.
Yep.
But this has everything defined in the MTConnect standard. So what we decided is that we can start to flesh out a series of C# libraries that we can use to help automate the consumption of this document and help facilitate developers to use that rigid object-oriented model that represents this in a way that they can produce other media. For example, C# code. If I want to automatically write C# code with this information backing it, we're going to create a library that helps facilitate that. Does that make sense so far?
Yes.